years. So clearly versions are important to LANDFIRE. And they're important to LANDFIRE because they're important to the users. Conditions change over time, and LANDFIRE tries to actually represent those changes over time. But it is important to understand that each LANDFIRE version is really developed to be the best snapshot of conditions for that time period as possible. It is not designed to necessarily be a time series analysis. Now, a program like the National Land Cover Database does try to be more of a time series data set, because it does go back and try to make products from previous years as compatible as possible to the latest product. But LANDFIRE really puts out a current conditions product. But what we know is people are going to compare versions. And they do that because there are many things that are important, such as, are there trends in the change in the landscape? Is what I'm doing on the landscape making the difference that I hoped it would? Are there unknown changes occurring on the landscape, etc.? So there's important reasons to compare LANDFIRE versions as well as other product versions as well. And of course, what are the issues with change detection and change analysis? Well, it's actually quite complicated, and it's actually quite messy. Is the difference or change that I'm seeing when I compare two LANDFIRE versions, is it real? Is it an actual change that I'm interested in? We'd call that a commission error if it's not. Are all changes of interest captured? Did I miss something? We might call that an omission error. And those errors occur because the life is messy. And I thank Tim Boucher, one of our TNC colleagues, for providing this particular graphic, because it is the reality, you know. Data sets are difficult to work with. There's a lot of things impacting them, and data sets are more like the snarling dog on the right than they are the cute puppy on the left. And we have to deal with that with multiple data sets when we're doing change analysis. There are often direct trade-offs, absolute direct trade-offs between omission and commission errors. It's almost impossible, might be impossible, but almost impossible to decrease both at the same time, because you're working with algorithms. And as you change the dials, the switches, the thresholds within an algorithm to include more change, you're typically also adding in things that you don't want. If you tweak the algorithm to eliminate things you don't want, you often leave things out that you do want. So those omission and commission errors almost always have this sort of correlative effect that's not useful to you. Now, that's not a mathematical certainty, like you can't reduce type 1 and type 2 errors in a statistical test at the same time. It's not a mathematical certainty, but it's highly, highly probable that these errors sort of happen when you try to help with one, you hurt the other one, and vice versa. So I kind of have this rule of thumb that I've developed for comparing versions, and this doesn't just apply to LANDFIRE. This applies to any versions where you're comparing across time or space or data sets or whatever, that typically, if you increase the size of the area that you're actually analyzing, and you increase the temporal time period that you're analyzing over, more years instead of less years, and then you reduce the level of detail that you're looking at, you'll create more useful comparison information. So if you have a small area, a small time interval, and a lot of detail in your change analysis, you're going to have a lot of noise in that data set. And it's going to be hard to separate the noise from the actual change that you're interested in analyzing. So that's a rule of thumb that I think applies basic across the board, no matter what you're comparing, what data sets you're comparing. But it certainly does apply to LANDFIRE, because LANDFIRE is a large landscape, regional, national product. Okay, so those are things that have to be kept in mind when you're comparing the versions. Because we know people are going to compare versions, we've created some interesting, I think, and useful materials that are posted on landfire.gov. Under the data products main menu item, and then the download mosaic data products item within that particular menu, you'll find these 3 documents, materials that will help you understand what the versions are, what was produced in the different versions, and then in the last link, they're the one that says comparing Landfire veg type, cover, and height across versions. There's actually a document that we created and posted. And I'm not going to go into detail in the document in the presentation. We want this to be short so that we have time for a conversation, but we can certainly look at it during the Q&A if you want to. But this goes into a lot of detail about the changes that occurred in between versions, either changes in process, changes in legend, changes in data format, etc., that occurred between versions that you should be aware of if you're going to compare vegetation type, cover, and height across versions. Okay, so this document is there for you to download, and we hope that you will if you do decide to compare different Landfire versions. Now, there's another important vegetation layer that people tend to compare, and this is vegetation departure. Many years ago, some of you may have seen this called fire regime condition class, which it never was. We shouldn't have ever called it that, but we did. But now we call that same layer vegetation departure because that's really all it is. It is not fire regime condition class. But people tend to want to compare across versions this particular product because it is a metric that's supposed to indicate the ecological condition, the ecosystem condition, vegetation condition, whether it's good or bad or in between. That's the purpose of this particular metric. So people want to go back to 2001 and see, oh, has the landscape improved in 2016? The problem is this is a complicated metric. It has a lot of components. We have monkeyed with those components and how we combine them in order to create vegetation departure over time to hopefully now, we hope, have set upon the process that we'll use now and in the future. And that's what you'll see here is in this chart for the different versions, at least through 16, it shows the different components of the metric and what has changed in how we compute it. Now, Landfire 2016 and 2001, they can be roughly compared. They're more similar than some of the others, but there are differences. So we should talk about those differences if you did decide to compare vegetation departure in 2001 to vegetation departure in 2016 and thereafter, because it can be a little bit tricky. We've even changed the schema, the values that we place as in terms of vegetation departure. Okay, it's a little bit different in vegetation condition class. So definitely, if you want to do that and you have questions, go through the help desk, submit a question. It'll probably end up coming to one of us on the Landfire team in order to answer that question. So as we get to the end of the presentation, I don't want you to be depressed. I don't want you to be frightened off from comparing versions if that's important to you. You can compare versions, but you really have to be intelligent about it. You have to pay attention to the area size, the time period that you're analyzing, the level of detail that you're analyzing. You have to think about what you really need. You have to think about what is important to you and what is not, because as you complicate the change analysis process, you make it harder and make the information less useful to you. So that's, I think, the extent of that. So now I think we can open it up for questions or conversations.
Yeah, thank you, Jim. Yeah, everybody feel free to chime in with your questions via, turn your camera on and speak or type in the chat, whatever is most comfortable for you. There's not a huge group here, so I'd say jump in.
And while you're thinking, I will reiterate again is, we hope that you will compare versions if it's important to you. And we will support you in trying to do that. If it is something that is critical to you, we have done it. We've done it for some clients in California. We've done it for some folks in New York, so it can be done We just have to make sure that it's done appropriately to create the right kind of information to support your work.
I'm curious if anyone has ever done the sort of time series work that Jim's talking about. Personally, myself, what I've done time series wise with LANDFIRE data is charted out disturbances from year to year over time. So I was wondering if anyone has dealt with the LANDFIRE disturbance data, or if anyone from the LANDFIRE group could reflect on that. You know, is it a good thing for me to chart disturbances over time to look for trends in amount of wind, for example, or one of the non-fire disturbances LANDFIRE maps?
Well, yeah, and Randy, just some of those layers are more comparable than others. Like disturbance, it's probably comparable across time, because
So,
yeah. Sorry, Inga, go ahead.
Just having done that disturbance presentation at Landscape Ecology, I kind of delved into some of that. And, you know, I think that 2011, 2012, right around there is they made some pretty big changes to how they process the imagery. And so I think, you know, from there on, it's pretty comparable. And from before that, it's pretty comparable. But I don't know about, you know, across that entire time span. I think that there were a much improved process around that time, 2011, 2012. Yeah.
Super useful, Inga. Thank you. Yeah, that's exactly the sort of thing that we need to be aware of. Thank you.
Yeah, and then in terms of, you know, different agencies submitting events, you know, I mean, that obviously has improved throughout the years, but yeah. And there's a lot more sort of national level perimeters accounting for different treatments and different events now than there used to be. It used to be much more piecemeal. I couldn't really give you an idea on dates on that, but Brenda would probably have an idea of how that's improved through the years.
Great. Thank you. An example that I remember, Inga, it's probably might still be there, would be the insects and pests. For example, it's still like Pennsylvania was really amazing at reporting that.
Right.
And then New York wasn't. It's like the insects just stopped at the state border.
Yeah, we had that problem at the border of New Jersey too. We're like, oh, I guess the insects don't cross the borders.
I see that Robert Zeal has his hand up. Thanks, Inga.
Okay, I guess you have to also lower your hand so it doesn't just stay there. I don't always have questions. I'm interested in knowing, you mentioned that there was this sort of threshold in processing of the satellite depictions. Is there a reason to think about distinctions in the satellite data itself? We go from Landsat 7 to Landsat 8. Is there a difference in, obviously there were some problems towards the end of Landsat 7's, useful life, but is there reason to be concerned about that sort of thing?
Inga, you're probably better to address that than I am.
Yeah, I mean, you know, obviously they had to do the scan line filling just like everyone else to be able to use that data once it started failing. But I don't know. I mean, I feel like that's Landsat's claim to fame, right? Is that it's a consistent data set through time. So I would say that wouldn't be as much of my concern, other than the Landsat 7. Yeah.
And I would say, Zeke, also, it's one of those things that's a fairly general, if I want to call it that, not thematically detailed layer. You know, it's disturbed, right? It's mechanical. It's insect disease. It's not, there's not 300 types, you know, that you're trying to distinguish on imagery. So the differences, now, if you go back to Landsat 1, you know, MSS or something, yes, but not in the 5, 6, 7, 8 satellite series, they're similar enough to where I would not worry a lot about that, except for the issues like Inga mentioned where they had the scan line drop out. And you have to do, you know, hand waving behind the scenes to fill those gaps. You know, that sometimes creates a little funkiness.
Yeah.
That's what I think.
Well, I'll follow up with a point. In the far north, NASA has funded this Above project. And one of the things they did was they took Landsat imagery from 1984 and produced annual depictions, a much simpler classification, of course, but you know, we've actually found that to be interesting. And, you know, the only question I've had was whether or not there were, you know, essential differences over time that make it hard to interpret what the Landsat satellites have been seeing over that period of time. You know, that 31-year history suggests to me that there might be potential to go back, you know, and use some of what you know today to perhaps produce classifications in past years.
Yeah, some of the things that we're talking about is trying to you know, make those relationships through time a little more clear. But that's sort of like, okay, that's like you know, this huge project over here. But we're hoping with cloud computing and some of that stuff that we're trying to move to, that will be a lot easier and faster to do.
Thanks.
Great question, Zeke. Thank you.
And just so you know, is just in the work that I've done and that we've done with a couple of groups like the California Air Resources Board in trying to sort of do some even 2-year, you know, comparing 2012 to 2014 to 2016. You know, we do find that that's pretty difficult. You know, there is a lot of mapping noise when you do that, even though remembering that 2012 and 14, they're updates of the same basic foundational layer. They're not even really independent, right? They're dependent upon the original layer. You still have some problems comparing them. And a lot of that comes back to legend changes when we make big changes to the legend. And you'll notice in 2016 are probably the biggest changes to the vegetation legend that we had, because we disaggregated wetland types. We added new ruderal types and things like that. So that's the first caution I would give you if you compare vegetation type, is that legend changes do cause work. You have to determine how that legend was managed over time to really extract the right information. The biggest change in EVH and height is the fact that now we use lidar to estimate height. So I think, Zeke, this is one of those instances where I think we did have a leap in technology that was not available early that does allow us to do something a little bit more precisely and accurately than we could in the past. So something that may, you know, some of the change you would see between 2016 in height and previous classes is just we're doing it better because we have this technology of lidar that we can use that we didn't have before. So there are some technology leaps that make a difference. And that's also allowed us to provide the data in more, with higher thematic resolution. So height is now delivered in 1 meter classes for trees, and 10th meter classes for shrubs, and then some for grass as well, and herbs. Whereas before, remember, we only had 5 categories of height: 0 to 5 meters, 5 to 10 meters, 10 to 25 meters, 25 to 50 meters, and 50 meters and above. So that's a big change that does complicate comparing things like existing vegetation height. But it was done for a good reason, to provide more effective data for that latest version that we create. We do hope that there'll be fewer and fewer of these changes unless there are some big technological leaps that we can take advantage of. Like Inga's talking about, using different processing algorithms because we have cloud computing, and AI and deep learning and machine learning and all those things. Because our first goal is to create the best product possible for that time period. That is our first goal. We actually hoped at some point, at least I did, I don't know if anybody joined my train on that one, that we would go back and recalculate 2001 vegetation departure using the same methods we used in 2016 departure, the same summary unit, the same reference values, etc., so that we could actually then do a cleaner comparison of ecological condition in 2001 versus 2016. Right now, that's a confounded comparison. Not highly confounded, but it is confounded. So I'm hoping that maybe we will find time to do that. Just not so far.
Well, this is Zeke again. I'll just follow up on that because I do think that having that sort of consistent kind of progression might allow us to learn more about the successional pathways, in the BPS models to be informed by actual change. We've only used this much coarser classification system, but we've actually tried to track individual pixels and accumulate those changes up and develop some trends in an obviously simpler landscape, right? The boreal landscape is simpler than what we deal with, across CONUS. But I think that there's, real potential to go from model to monitoring in that detection of change. I applaud your thinking about that, and we'll see where we go.
Yeah, thanks. Yeah, we've thought of all kinds of things we'd like to do. Someday maybe we'll find time to do them. And that's a really good suggestion, because that would be helpful in sort of evaluating some of the models anyway, and the successional pathways and rates and stuff that we've put into models and that we use. That would be helpful rather than having to rely on expert opinion, literature, or models like FVS or RVS or something like that. So thanks for bringing that up.
Yeah, I don't know how far we want to get in that conversation, but if you think about when we model vegetation, we're using the plot data, and we're kind of taking many years of plot data to do that, and applying it to kind of current imagery. And so if you think about separating that plot data by years and then using the imagery from that year, and being able to do that consistently back through time, you may not have plot data for, some areas for some years. And so how that all can be sort of backcasted is, becomes pretty complicated pretty quick, but it's exciting to think about for sure.
So I thought I would share my screen for a moment and show you quickly. I'm going to kind of flash it because I don't want to get into the weeds of details too much. But another difference that that Jim did not mention, which is over the last few years, we updated as many of the biophysical settings models as we could. We got review on roughly 300 of them. And as Jim mentioned, there's over 900. So we didn't get to all of them. But I'm going to show you a map that shows sort of the PICS level of change between the original LANDFIRE models and the ones that we have now for the mean fire return interval. And I'm not even going to turn on the scale, but I would just want you to see you know, the amount of area that has changed because, you know, where the fire regime changed because of the changes we made to the models. I think there's a lot of improvement. And I'm happy with this, but if you were to change any of the, or if you're going to look at any of the data sets that are linked to the biophysical settings models, such as succession class or mean fire return interval or vegetation departure, any of those data sets, if you compared the most recent to an older version, you would get some artificial changes because of all the work that we put into updating things. So yeah, it's very real. It's very real, and I appreciate what Jim said, that our first goal is to create better products, and we hope people can use them over time. But making the best products we can is the goal number one, even though we sacrifice some comparability going back in time.
And I'll say once again, I think you can do that. Just we have to do it smartly. You know, that's because we have done it, and it does work. But you can't just necessarily take a 2012 product and a 2016 product, combine them, see what the changes are, and not be and not expect to have some weird things in there that are not real. I think they will be in there because of all the changes that have happened.
So I just wanted to pause for a minute, and no pressure, Caleb or Art, but I wanted to give you the floor for, if you had questions. Again, no pressure or expectation. Just wanted to throw that out there if you had questions from your part of the world.
Yeah, I can even just chime in. I'm just kind of listening. I might be we don't really have any preserves that I burn on, but we work with the Forest Service and our state, Illinois Department of Natural Resources, and I go out west and have done wildfire on interagency hand crews the last like 4 or 5 years. So I don't do a whole lot of monitoring. I'm more of a practitioner, so I just kind of joined the call to just to join in. But yeah, I don't really know if I have a whole lot of we're going to do some fuels monitoring for the Forest for they had a different pot of money this coming year, and take 390 a weather observations class. But yeah, I'm kind of more of a practitioner and don't do a whole lot of monitoring because we only have 3 preserves and it's in the Cache River down here. So swamps, we don't really do a whole lot of burning in anyways. But yeah, we just had a record season. At least this past spring, we burned 14,500 acres that we assisted on just the Shawnee. And then I broke off with our state resources and did about another 2,200. So there's just 6 of us down here, and we kind of just do more in the field every day. And I do a lot of GIS work for our, we use collector app and field apps and stuff, but yeah, I don't really do a whole lot of this. So I'm just kind of listening in. So otherwise I chime in a little more.
Yeah.
So Caleb, you said you've done some GIS work. Have you looked at, say, LANDFIRE vegetation data in Southern Illinois, in the more forested areas of the state that have not been converted to agriculture? Because we know there have been some fires down there along the Mississippi River, et cetera. Because Megan, I said Megan Dettenmeyer. Megan, what's her name?
Savasky.
Yeah, did talk to us about some that were down there. So have you seen that?
No, I really haven't done I got on the site and looked at a whole lot of stuff.
Okay.
The only wildfire we had this past year was just a 200 acres, nothing huge.
Okay.
But yeah, just some locals burning trash that got in, and we have some mine reclamation sites that are a lot of grassland that kind of catch from time to time. But we don't have a whole lot of wildfires, but I haven't really looked at the data much down here.
One of our colleagues did do the fire assessment for Illinois. Sarah Hagan, if you know her in Illinois, then and she used some LANDFIRE products to do that. So if you have any comments about that, we'd love to hear it.
Yeah, I really don't. I don't know if she'd be on or not. She kind of forwarded it to me a little while back, so I just joined this just to
welcome.
See what it's about. Yep. Thanks.
Great, and not to punish you, Caleb, for mentioning your work. But yeah, if you ever do review LANDFIRE data, give it a go. Let us know how it holds up. And I'm assuming that we end up getting your your plot monitoring data from the federal databases, but I was just curious about that because plot data drives our quality pretty much.
Okay. Yeah, I don't have a whole lot to add in on that either. Sorry.
That's
Hey,
all right.
no
Thanks,
worries.
Caleb.
Yeah, I would be interested, Caleb, if you get a chance to look at our fuel model, our surface fuel models for your area, how they look.
Yeah, I'll definitely look into a little more and share it with our crew and see if we can kind of check some stuff out and chime in a little more, or do a little more of this.
All right.
And you did say you do partnership work on the Shawnee National Forest, right?
Yeah, we pretty well just assist everyone down here, and we just had a Women
Okay.
in Fire initiative too,
Okay.
where the next 3 years there's a big grant with the Forest Service. We're trying to diversify the wildland fire crews. So I'm actually supervisor and mentoring 6 different female practitioners, 2 each year. They just started first rounds in January. So we've been doing a lot of training, hands-on. That's where the fuels monitoring is going to come in this summer. Forest Service had a separate pot of money that they want us to get a lot more of that experience and do a lot of monitoring, and so that'll kind of applicable to what we're talking about here. We'll get a little more experience with that.
We can take questions too that are not related to versions. So if Arturo or Eli or Zeke or anybody else have some other questions, we'd be glad to try to have those as well. Not just related to the versioning topic today.
Hi, everybody. Arturo here. Can you guys hear me?
Yes.
Okay, I apologize for the audio. I have you guys on speaker, and I'm currently driving to a project. So unfortunately, I was unable to give this lecture, if you will, my undivided attention. So I'm definitely looking forward to the recording. But just to give you some context, how I came about seeking more information with LANDFIRE and modeling that will give us our existing condition. I as well heavily involved with monitoring on the San Bernardino. So with my position, I'm involved with prescribed fire, mechanical treatments, hazardous fuel reduction, burn plans. And one of the projects that got me looking into fine-tuning our existing condition, it's I don't know if you guys are familiar with it, but it's the Lido Creek Community Defense project out here on the front country. And, we're looking for our existing condition, and we have existing veg layer. But when I was looking at the veg layer, I work with GIS a lot as well. I was looking at the GIS layer, and being that I'm real familiar with that project area, I noticed a lot of discrepancies, if you will, in the species composition. So that kind of got us digging a little more, trying to find something that's tried and true in terms of existing condition. And, I have limited experience with IFTDIS, and, I use that program, and typically we've been relying on the existing GIS veg layer. So I guess I said all that to say, that got us going down a rabbit hole and seeking, something that's a little more accurate, if you will. And, we on the forest, we currently do have lidar surveys underway, but unfortunately, due to funding, we're not going to be able to get our whole forest, and the Lido Creek project that I mentioned is not going to be covered under that lidar project. So I'm just here trying to learn more about LANDFIRE and its usage.
Arturo, where are you again? I didn't understand where you were actually located.
That's going to be the San Bernardino National Forest.
Okay, San Bernardino. Okay. Yeah. Okay. And you were talking about discrepancies in the vegetation type layer itself.
That's correct. So like,
Okay.
for example, there's so we pulled the veg layer, and then we we made a, what do you call it? A chart or a graph, if you will, that depicts the percentages of the species composition, and
Mhm.
and just walking out on the project and you know, just getting familiar with the area. There's tons of manzanita stands out there, and when we got the veg layer and we created the graph in terms of percentages, I mean, it was not even a half a percentage
Okay.
worth of manzanita there. And I understand that it's outdated, and you know, technology is advancing and so on and so forth. So I'm just trying to wrap my head around and get my hands on the latest and greatest platform for our existing condition.
Well, if you have a chance, we would like to see specifics on that, you know, maybe even send us a screenshot, you know, so that we could see what's going on and maybe look and see what's happening. Is it something in the algorithms that we're using? Do we not have any plots for the manzanita types? You know, things like that, Arturo, so we can investigate a little more. But it would be nice to have specifics on the issue so that we could follow up. Did you look at 2016 data, or was it one of the earlier versions? Do you know?
Don't quote me, but I want to say it was a 2016 layer.
Okay.
I can confirm that, and you know, there has been a lot of disturbances here in Lido Creek. If you're familiar with the area, you know, Lido Creek is adjacent to the Cajon Pass, which is notorious for wildfire. So it's probably just, you know, the process of ecological succession that type converted, and now we're starting to see more manzanita being more resilient, or I don't know, just you know, thinking out loud here. But yeah, that's one of the red flags that popped up during this project. And I mean, I know we could only work with the information we have, but I just kind of wanted to wrap my head around the methodology in terms of how we get our existing condition.
Okay. Well, thanks for bringing that to our attention. And I said more information would be helpful so that we can follow up to investigate, Arturo. If you have the time and the ability, that would help us a lot.
Yeah, I'm more than willing. It'll help me understand this as well. If you guys can put an email address in the chat box, or just email me directly when I get to the office, I can pull up the project and coordinate with you guys.
Okay, thank you.
You know, Henry Bastion here, Archer. I really appreciate you highlighting this. I think, you know, maybe one thing we need to look at is relative to when we say existing vegetation, sometimes people, I think, get tripped up relative to the legend that we use. And because the legend is it's called ecological systems, it will have kind of this array of different vegetation types represented, but many times, and what sounds like to me, and maybe I'm a little bit off here, but it'll be good to validate with you, Arturo, is a lot of users are like, hey, I would like just a good dominant cover type map, you know, represented for my vegetation. So maybe an example to help with this, let's take quaking aspen. For those of you on the call that are familiar with that specific species, quaking aspen does not show up, in our ecological systems map as, a key type. It's associated with other vegetation types. So many times people will be like, well, gosh, Landfire missed this. I'm standing in a forested stand of quaking aspen, and this is showing me some kind of mixed conifer, ecological system type where, yes, quaking aspen is represented, but it's kind of that earlier successional state. So what I'm hearing you saying here with the manzanita sounds like there may be some parallels to that we need to take a look at relative to the legend, ecological systems, and what you're actually seeing on the ground. So yeah, I think if we can email back and forth and kind of, dig into that, that may help us then say, okay, I see exactly what you're saying, Arturo. When you pull it up, you look at it, it's like, yeah, there's just not enough manzanita here. We've got to figure out how can that classification and or the legend help us get closer to that dominant cover type that people may be actually seeing on the ground versus just these broad ecological systems categories. I don't know if that helps or not, but just an observation as I'm listening to you talk.
Yeah, no, definitely. And I think that's what happened here. I definitely did put a bullseye on the legend, if you will, and, you know, contrasted it with what I was seeing out on the field. And again, you know, that's, and I apologize, you know, I definitely don't understand, you know, our capabilities and limitations, but I think this forum here will definitely help me wrap my head around that and understand the tools that we have accessible to us and you know, apply them accordingly.
Yeah, right on. No apology needed, because we're all here just to learn. So that's why these sessions are here, is just to throw it out. We talk about it, and then we, you know, help each other kind of discover and learn. So right on. Good job.
And Arturo, I put the help desk in the chat box so that you can see how to connect to the LANDFIRE help desk and the general TNC email for LANDFIRE. So that's there for you to use. Sorry, Randy.
Yeah, Arturo, Randy Swati here. I'm in Marquette, Michigan, and I definitely do not know your landscape very well. So I can just tour around an ArcMap. And I just pulled it up for the fun of it. And I think I see what you're saying. I see the pinks of the urban area, and then I see a little band of brown, which I guess would be, you know, some sort of chaparral or something like that. And then I see it move into more tree type vegetation types. So it's kind of like we have all this green rimmed by a little bit of brown, which is probably the chaparral, where you might have the manzanita. Then it goes into, you know, to the west we have all the urban areas, and then to the east we have brown, you know, different color brown, which would be something else altogether. My map is kind of slow at the moment drawing your borders. But anyways, I think I see what you're talking about, and it would be really interesting to dig in more, either through the help desk or through one of us directly.
Yeah, definitely. I'll take you guys up on that, and I'll reach out to the email address in the chat box with the help desk.
I just wanted to maybe describe the process that Henry was alluding to, and that we talked about, how important the plot data is for our mapping. So so when we get plot data, we put it through our process, and we look at the species that are at the plot, and then the cover associated with each of those species. And then that gets put through what we call our auto key. And the auto key is taking those species with the most cover and saying, okay, those are the ones that are kind of describing this ecological system. And it puts it in one of those legend categories. And so then we use that labeled plot with its legend category, and we overlay it with all of the imagery. So your NDVI, and all of that imagery, and the different physiological things like precipitation, and all of those things that go into the model, the variables that go into the model. And we say those are related at that spot, right? All of those things on the landscape are related to what that plot is called in our legend. And then we say, okay, that's the relationship there. And so if you go to another pixel and it has all those same imagery layers underneath, we're going to assign it to that ecological system that we saw over there was related. And so so that's really that's how it works. And so it's just it's the classification and regression tree model that we impute across the landscape based on all of the imagery that goes with that plot. And so, there's several ways that can go wrong, right? Like, did the person, gathering the data, do it right? Did the auto key work correctly to assign it to that particular ecological system? Was there something off with the imagery, So anyways, there's a lot of ways that can go wrong. And so when we get examples of, areas that it did go wrong, then it helps us to refine that process. So.
Thanks for that, Inga. You're really good at explaining things. I appreciate it.
Yeah, well done. I guess I want to do a little go back if Zeke's still with us. I'm sorry for my connection. I'm just coming in over the phone. But to what Zeke was talking about earlier about going way back in time, I'm wondering, Zeke, if you could talk a little bit about what do you see some of the, the why or the value of what could be done there. And I guess let me compare and contrast this, and this might help. So if we look at where LANDFIRE has been mapping, we started in, circa 2001. We talked about the updates and a few of the changes that, have occurred to get us to where we're at today. And if we compare it with what I'll call it a sister effort, National Land Cover Data, NLCD, that data set, they have gone more back in time to look at that land cover types of change over time. And then, of course, for that program, looking at those broad categories, it's really helpful to, think about, well, how is urban, for instance, and some of the other vegetation changing, across particularly the United States, but, in a large area, how is that changing over time? And so I'm curious from your perspective, thinking about it through the lens of what products LANDFIRE produces, how we might be able to say, well, yeah, the why or the value of us being able to go back and do some of that, because it could be within our reach. We just have to then say, that's important because, XYZ. And if you can help us, maybe articulate a little bit of that why and the value, that could help us explore this a little bit further. Are you catching what I'm talking about?
Yeah. I'm part of a project, an NSF project where we're evaluating the changes in hazards and the associated risks across 3 urban domains. So you're right up the same alley in Anchorage, Fairbanks, and Whitehorse. And we're looking at wildfires, we're looking at permafrost loss, and we're looking at freeze, thaw kinds of problems that occur and are occurring potentially with increasing frequency with climate change. And with permafrost and wildfire, the landscape really drives those changes. Modeling forward into the future, the landscape is really a slippery slope. And we've been using the history over these 31 years to help us understand the sort of variability in disturbance, the variability in impact, and to help inform us along with changes in climate as to how we're going to disturb and depict those future landscapes. So it's a very uncertain outcome whether we'll even be successful in that. But I think we've learned a lot just comparing 1984 to 2014. That we see that the intrusion, that's maybe not the right, has the wrong inflection to it, but the intrusion of urbanization and development into natural landscapes and what it's done to the hazard. That actually we're seeing that it's reducing the hazard, and I think normally we think when people build into those areas that their risk is increasing, but at the same time they're changing the landscape so that the hazard and their risk from it is actually perhaps being mitigated by their actions themselves. So there's a number of those kinds of things that we see, sometimes even the simpler look can help us understand and appreciate trends in the impact of wildfire disturbance and how we depict that going forward, how quickly we see those recoveries occur. The modeled information, I think, is pretty good, but whether it confirms it or adjusts it or refutes it, some real data along those kinds of lines has been informative. I certainly am not a magician with GIS, but one of the other folks in our group was, and they were able to use the, and I can't remember the name of the chart, but it actually shows you directions, where it goes from one type to another type over time. And it's pretty informative stuff. So I do think that there is reason to consider whether you can take some of your more general types, like the EVT group classification, and see if in fact you could perhaps carry those backward, in more simplified ways for precisely this kind of look.
Excellent. Yeah, that's super helpful, Zeke, because I was going to say I can guess, and some of my guesses are in line with what you're at, but thank you for articulating that. We'll probably need to do some follow up on this. So thank you so much.